Fluid statics. Understanding the forces within fluids. Welcome to Fluid Statics, where we explore the principles and phenomena that govern fluids at rest. Archimedes' principle states that a submerged body experiences an upward force called upthrust, equal to the weight of the displaced fluid. This principle is crucial in understanding buoyancy. This explains why ships float and hydrometers work. The upthrust counteracts the weight of the object, allowing it to float if the upthrust is equal to or greater than the object's weight. Similarly, Pascal's law tells us that pressure applied in an incompressible fluid is transmitted uniformly in all directions. This means that any change in pressure at any point in the fluid is transmitted throughout the fluid. This principle enables hydraulic systems and brakes to function efficiently, as the pressure applied at one point is transmitted to another point, allowing for controlled and powerful movements. Upthrust, pressure in fluids, and buoyancy are key concepts in fluid statics. Upthrust, also known as buoyant force, is the upward force exerted by a fluid on a submerged object. It is given by the formula F_up equals ρ times V times G, where ρ is the fluid density, V is the volume of the displaced fluid, and G is the acceleration due to gravity. Pressure in fluids is the force exerted by the fluid per unit area. It is calculated as P equals ρ times G times H, where ρ is the fluid density, G is the acceleration due to gravity, and H is the height of the fluid column. Buoyancy is the ability of an object to float in a fluid. It ensures stability, with the center of buoyancy and metacenter being critical for floating bodies. The center of buoyancy is the point where the buoyant force acts, while the metacenter is the point where the buoyant force and gravitational force balance each other. Surface tension, another key property of fluids, allows small objects to float and droplets to form on surfaces. Its formula is T equals F/L, where T is the surface tension, F is the force, and L is the length over which the force acts. The law of flotation states that a floating body displaces a volume of fluid equal to its own weight. This principle is crucial for designing ships and other floating structures. Other vital topics include viscosity, which measures a fluid's resistance to deformation, and the distinction between laminar and turbulent flow. Reynolds number helps predict whether flow will be laminar or turbulent. Finally, Bernoulli's equation connects pressure, velocity, and height in fluid dynamics, and is applied in airplane wings and Venturi meters. From basic principles to real-world applications, fluid statics forms the foundation of countless engineering marvels. Want to dive deeper? Let's solve some examples together.